Very good evening. You have done certain part of that chapter called chemical bonding. Okay, and we are going to go into a very special phenomena. Phenomenon means what? What is the meaning of phenomena? What is the meaning of phenomena? Phenomena means one and only. Phenomenon means one and only of its type. One and only of its type is called a phenomena. The sun rises in the west, no? Ah, very good, very good. You know that. Sun rises in the west. East. Very nice. And it sets in the north, no? West, west. Always west, west. Huh? Not west, no? West. And because of this, the world is running, no? The half day which we have is light, the other part of the world is dark. Because of this sun's movements, okay? We are getting nights and days, okay? So that is a phenomena. That's a phenomena. One and only. You can you see the moon rising in the east and setting in the west? No, 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 no. Is it? So phenomena means one and only one of its type. And that phenomena today is hybridization. Hybridization of orbitals. Hybridization of atomic orbitals. What are the atomic orbitals? As far as our knowledge is there, how many orbitals are there? S, P, D, F. In the first main energy level, we have 1. Okay. In one subshell, and in that we have only 1 orbital. S में खाली एक orbital रहता. In the second main level, we have 2 subshells, S and P. In S we have 1 orbital and P we have 3 orbitals. In the third main shell, we have sub energy levels S, P, D. Sub energy levels S, P, D. And in S we have, as far as already we know, we have only 1 orbital in S sub level. In P we have 3 orbitals. You know odd numbers, no? 1, 3, 5, 7. S, P, D, F. And what is an orbital? A orbital is a region around the nucleus where the probability of finding the electron is more. The probability of finding the electron is more. For example, now Bilal is there. Where is the probability of finding Bilal on a holiday? Is it in the house or in the school or in the streets? So Bilal's orbital is streets. The orbital of Bilal is streets. Is it? Bilal means some X, a student called X. Just I named that name as Bilal, but it is X. On Sunday, Mr. X will not be seen at home. He will not be catching the books. Neither will be seen in the school. Neither will be sitting in a study room. But he is seen on the streets. So he is street Bilal. So the orbital of X is streets. The probability of finding X is where? Not in the house, not in the study room, not in the bedroom, not in the ground, not in the school, not in a friend's house studying together, combined studies, but he will be seen on the streets. So the street is his orbital. So leave that temporary street, that temporary orbital. What are permanent orbitals? The orbitals are the region around the nucleus where finding electron is maximum. Finding electron is maximum. The probability of finding electron is maximum in that regions. And those regions are called orbitals. Those regions are called, got the point of orbitals. So in the sub-energy levels, we have orbitals. S, P, D, F. And now we are talking about hybridization of those orbitals. Hybridization of those orbitals. Which orbitals? S, P. Come on, we'll go into the topic. Shall we go into the topic? Hybridization. So, this is hybridization. What is hybridization? Let me tell you. Okay. It's the final time that I'm going to tell you again. And most of you don't know it. If you know also, you don't know. You have a vague idea, not a very clear idea. You are having only a vague idea. Let it be clear today. Let the idea become clear. Let you understand the process of hybridization thoroughly. Okay. Until now, it is like we have got it, and it's also we are having some um, doubts about it. In your minds, you feel like that you got it, but yet you are having certain things to be clarified. Okay, so get it clarified today. आज क्लैरिफाई हो जाना, जो भी धुंधलापन है वो निकल जाना, क्लैरिटी में दिखना. व्हाट इज हाइब्रिडाइजेशन? ओके, इट हैज टू बी क्लियर. No more chances, no more performances. You have to do it now. The final performance is yours. Okay, mine is over by today. Okay, again I'm not going to teach hybridization, maybe another class. If today the time is not sufficient, it will go into the next class. Okay, right? So what is hybridization? Come on, let me tell you. It is a phenomena. It is a one and only one of its type. One and only one of its type. Phenomena means of intermixing of orbitals. Intermixing of orbitals. Which are the natural orbitals? Which orbitals? The natural orbitals. S or P or D or F. The natural orbitals. Intermixing of those orbitals. Okay. Which orbitals? S, P, D, F. One with its own self or one with the other. S with S or S with P. S will overlap with S or S will overlap with P. Okay, that I mean to say intermix. They will intermix with each other. The orbitals will intermix with each other. Okay, and after intermixing, what happens? They are reshuffling themselves, re re changing their shapes, regaining new shapes. Okay, okay, and reshuffling or redistribution. It means the electrons are going here and there, the shapes are changing and all. You know the real coconut tree and the hybrid coconut tree. Real coconut tree grows to a very great heights, but the hybrid will not grow that much. Okay, so now from the original orbitals, we are going to get hybrid orbitals. We are going to get hybrid orbitals. After reshuffling and redistribution, what we are getting? Same number of orbitals. Those are called hybrids. Those are called, we are going to get same number of orbitals. How many intermixed? So many hybrid orbitals. If two natural orbitals will intermix, we will get two hybrid orbitals. समझ में आया? कितने मिलते, जितने इंटरमिक्स होते उतने नए आते, उतने हाइब्रिड्स आते, उतने कितने ऑर्बिटल्स एक से एक इंटरमिक्स हो जाते उतने नए ऑर्बिटल्स होते. दो मिलके तीन नहीं आ सकते, दो ऑर्बिटल्स नेचुरल मिलके तीन ऑर्बिटल्स नहीं आ सकते. यू कैन गेट ओनली टू hybrid orbitals because two orbitals are intermixing. We can get only two hybrid orbitals. What are those new orbitals called? They are called hybrid orbitals. What are these orbitals and what are these orbitals? We are having two orbitals here in this definition. This is intermixing orbitals. These are intermixing orbitals, the natural orbitals. These are the, and these orbitals are formed after reshuffling and redistribution. The new orbitals. The new orbitals. And these are called hybrid orbitals. These are called after intermixing, after reshuffling, after redistribution, the new orbitals formed are called hybrid orbitals. And what is their lakshan? What is their qualities? Their qualities are, they have, those hybrids have equal properties like energy and shape. The new hybrids which are formed, the two, suppose two hybrids are formed. How will the two hybrids be? They will have the same energy, then they will have the same shape also. Got it? Once again. Intermixing of orbitals. Which orbitals? The natural orbitals. S and P. Okay. How many are intermixing? S and P. Two. Two are intermixing. After intermixing, there is a certain reshuffling and redistribution. After that, we are getting same number of new orbitals. Same number of, and those new orbitals are called hybrid orbitals. And what are their properties? They will have same energy and same shape. The hybrids will have same shape and same energies. Okay. Now we can explain this with an example. Formation of beryllium chloride molecule. Formation of so we know the atomic number of beryllium is how much? What is the atomic number of beryllium? Beryllium. What is the atomic number of boron? 5. Beryllium 4. Atomic number 1 hydrogen. Number 2 helium. Number 3 lithium. Number 4 beryllium. Number 4 beryllium. Number 5 boron. So beryllium is 4. Beryllium is okay. So The atomic number of beryllium of ground state. Why I am maintaining ground state is number of protons is equal number of electrons. In a ground state atom, the number of protons will be equal to number of electrons. And what is atomic number? What is this atomic number? It is the number of protons. It is the number of protons. Number of protons are indicated by atomic number Z. Atomic number Z. Okay. Number of protons are indicated by atomic number Z. Okay. So, in the ground state, the number of electrons will also be 4. Why means the net charge will be 0. The net charge will be 4 protons plus and 4 electrons minus. Plus and minus cancel. 0. The net charge is 0. So, those atoms are called atoms of ground state. We are taking beryllium of ground state. We are taking beryllium of ground state. So what is its atomic number? 4. Means number of protons 4. It adherently means that the number of electrons are also 4. Protons 4 create electrons kete 4. Why means you can see that I have not created any charge to beryllium. Plus nahi hai, minus nahi hai. It is chargeless. Means it is ground state. It is ground state. So number of protons is equal to number of electrons. Now we know the number of electrons is 4. We know the number of electrons is 4. So we can write the electronic configuration. We can write the electronic. So the electronic configuration will be 1s2, 2s2. 1s2, 2s2. But beryllium in the excited state, it will be 1s2, 2s1, 2px1, 2px1. So the outermost orbitals are now the intermixing of orbitals in the present in the outer shells. Outer shell. Second shell. What are the orbitals present? 2s and 2p. 2px. 2s and 2px. Two orbitals are present in the outer shell. What is the outer shell? 2. K, L. This is L. L means N is equal to. N is equal to principal quantum number 2. What are you seeing like that, man? N, main levels are indicated by principal quantum number, no? Main levels are indicated by principal quantum number. So N is equal 1 means K shell. N is equal 2 means L shell. N is equal 3 M shell. N is equal 4 M. K L M N. K L M N. 1, 2, 3, 4. Okay. So N is equal 1 K shell. N is equal to L shell. N is equal 3 M. N is equal 4 N. Okay. So now outermost shell is N is equal to L shell. L shell. And what are these orbitals? Almost same energy. Almost same energy. These both are all having almost same energy. Not equal energy, but almost equal energy. Not exact same energy, but almost equal energies. Now these two orbitals will intermix. The intermixing. Outer shell. Which is the outer shell? L. What are the orbitals? S and Px. S is one orbital, Px is the other orbital. These both will intermix. After intermixing, they are redistributed into same number of orbitals. We are going to get same number of orbitals. S orbital is spherical in shape. P orbital is dumbbell in shape. So it has to be like this. S orbital intermixing with Px orbital. S orbital is spherically symmetrical. S orbital is spherically symmetrical and P orbital is dumbbell shape. But they will reshuffle. Means they will change their positions. Okay, and after reshuffling, we will get like these ones. You're going to get the hybrids. These are the hybrid orbitals. These are the hybrid orbitals. After the redistribution and reshuffling, the new orbitals. The new orbitals. Two orbitals are intermixing, two orbitals are formed. But they are reshuffling themselves and they are redistributing themselves. They're getting different shape. But both of them will have same shape and same energy. But both of them will have same shape. Same shape. Are they not having same shape? Maybe I'm not perfect in the diagram over here, but you can see they are almost having same shape. Same shape and same energy. Same shape and same energy. So these are hybrid orbitals and their name is sp orbital because s orbital intermixed with px. S orbital intermixed with p orbital. Okay, so it is called sp hybrid orbitals. These both are called. Can you see a difference over here? नेचुरल एंड हाइब्रिड्स, नेचुरल और हाइब्रिड्स के अवतार में फर्क दिखाई दे रहा. नेचुरल कैसा है? एस ऑर्बिटल गोला स्फेरिकली सिमेट्रिकल. पी ऑर्बिटल कैसा है? डम्बल शेप. लेकिन रीडिस्ट्रीब्यूशन और रीशफलिंग होने से बाद कैसे आ गए? ऐसे आ गए दोनों. सेम शेप, अलग शेप. अलग शेप हियर. Natural orbital is spherically symmetrical and it is dumbbell shape. But the sp orbitals both are having same shape and same energy. They're almost equal energy. Here, not equal energy. Almost equal energy, but not getting the point here. You're getting the point here. Almost same energy but equal energy. These are having almost same energy but these both are having same energy. That is the difference between the natural orbitals and the hybrid orbitals. Okay, shape अलग है, इधर shape same है. Energy is almost equal है लेकिन इधर पक्का equal है. Once again, understood the point? What is the difference between the natural orbitals and the hybrid orbitals? What is the difference between natural orbitals and hybrid? Natural orbitals, you can see they are having different shapes. They are having hybrid orbitals. They are having same shape. They are having same shape. Next, original orbitals are having almost equal energy but not equal energy. Almost but not equal energy. Almost is not equal. Almost बोलते 2.1 almost equal but that is not equal to 2.1. Can we say equal? No. But we can say almost equal. We can say my age is 2 years. Pratap's age is 2 years 1 day. 2 years 1 day. So what are we going to say? Almost equal. But we cannot say equal. Got the point now? I think so. You understand the point? I think so. Almost है लेकिन है नहीं. Almost है लेकिन है नहीं. Equal है नहीं. Almost equal है लेकिन that is the point. It is almost equal. But not equal. But here equal. So what is the difference here? You got it, I suppose. This period will take a long time. The next period will take a shorter time. When I give you the basics, when you understand the basics, the examples are easy to deal with. एक basic बोल दिया तुम्हारे को, foundation बोल दिया. When I gave you the foundation of hybridization, then the remaining examples would be comparatively easily done. The first one will take a lot of time. It will take a lot of time for getting it into your heads. Okay, so physics is a subject is very interesting. When a good teacher teaches it, even a most dull topic becomes a very interesting topic. When a when a seasoned teacher, when a professional teacher, when a experienced teacher teaches it, the most of boring topics will be changed into a very wonderful. I mean to say more attracting than a most favorite cinema of yours. Cinema ఎంత attraction గా చూస్తాం మనం. How we watch cinemas without disturbing ourselves. Na so much we are fixed. We are glued to the television sets. Atla you can see that everyone over here are total eyes are fixed on the board. Everyone's eyes are fixed on the board. So what does it suggest? The teacher is getting into their heads. The teacher is getting into their heads. Clearly understood. No one is wavering his head. No one is moving his head. It means he's trying to understand what is the topic over here. The topic over here is about hybrids. About hybrids. Did we get the hybrids? Why we got only two? Why we got only two? Why didn't we get three? Tell me anyone. Why we got only two? Why cannot get three? Into same number of orbitals. Into same number of orbitals. After redistribution, after reshuffling, we get same number of orbitals. And what is the difference between these two now? Almost same energy, but same energy. Different shapes, same shapes. Different shapes, same shapes. The natural ones are having different shapes. The hybrids are having same shape. Almost equal energy, but perfectly equal energy. Okay? Now that is about beryllium. Coming to chlorine, chlorine has its atomic number as 17 and it is not the excited state. This is the excited state. This is the but chlorine is of the ground state. Chlorine, we are talking about chlorine of ground state. Okay, 1s2, 2s2, 2p6, 3s2, 3p, 3p, 3px, 3py, 3pz. 3 orbitals are 3, no? So 2 plus 6, 2 plus 2, 4, 4 plus 6, 10, 10 plus 2, 12, another 5. And according to above, the electron will occupy orbitals having less energy. According to Hund's rule, first the degenerate orbitals have to be half filled. The p orbitals are called degenerate orbitals. They are called degenerate. In the degenerate orbitals, first the electrons will half fill the orbitals. अभी हमारे हाथ में 5 है. अरे you know mathematics, no man? You are not LKG, no? You are 10th class. How many electrons are there? 17. Already how many are filled? 2 plus 2, 4 plus 6, 10 plus 2, 12 are already filled. Another 5 are there in the hand, at hand. 5 are there at hand. How to distribute those 5? How to distribute? 2, 2, 1. Huh? Is it 2, 2, 1? Can you distribute 2, 2, 1? No. Pairing cannot occur before half filling. So we have to half fill the orbitals. Hund rule. According to Hund rule, see we are getting to Hund's rule also here. అంటే इसको बोलते बोलते मैं किधर आके बोल रहा हूं तुम्हारे को अफबार रूल बोल रहा हुंड रूल भी बोल रहा अफबार रूल क्या पहला लेस एनर्जी बाद में ज्यादा एनर्जी को भरना ओके हुंड रूल क्या बोलता डीजेनरेट ऑर्बिटल्स को पहले आधा भरना degenerate orbitals should be half filled, then only the pairing can occur. So 5 electrons are there at hand. Now first electron किधर जा सकता किधर भी जा सकता, किधर भी जा सकता, देयर इज नो सीरियल नंबर, इट कैन गो एनीवेयर. हाफ फिल करना होता, पहला वाला को करता 3px को करता या 3py को करता या 3pz को करता, वो नहीं, हाफ फिल करो, दैट्स ऑल. सेकेंड वाला किधर जाता, एनीवेयर, सेकेंड वाला चलेगा. थर्ड वाला किधर जाता, इधर जा सकता. विदाउट हाफ फिलिंग यू कैनॉट टेर, विदाउट हाफ फिलिंग you cannot take. That is the Hund's rule. That is the Hund's rule. So first you have to half fill. First you have to half fill. Right? Half filled हो गया. Now you can start pairing. Now you can start pairing. How many more electrons I am having at hand? 2 more. So 1 and 1. That is the Hund's rule. That is the filling of the orbitals in chlorine. Filling of the orbitals in chlorine happens like that. Which orbital is half filled now? 3pz. 3pz. So the 3pz will come in. Now here we are having how many electrons? 2 electrons. 2 electrons. Okay. You can see the electrons. Why the arrowheads are opposite? Why the arrowheads are opposite? Opposite spin. Opposite spin. In an orbital, the electrons will have opposite spin. They will have opposite spin. One spins in the clockwise direction. The other electron will spin in the anti-clockwise. That is the significance of that arrowheads. Arrowheads are opposite, indicating one is spinning in the clockwise direction, the other is going in the anti-clockwise. See how much matter is there to be told. So that is called laying the foundation before the building. Laying the foundation before the building. And you very well know that the foundation has to be absolutely strong. Right or wrong? How the foundation of a building should be? बांधे से 2 दिन के ऊपर क्रैक आना, लड़खड़ आना, no one will expect such a building. No one would like to live in such a building. Anyone would like to live in a building where the foundation is spot on, very, very strong. Right? Correct or wrong? So am I laying a strong foundation? I feel that I am laying a strong foundation. Okay? So I already taught you how to fill the orbitals. Now again, once again I'm reminding you what is Hund's rule. Hund's rule say that the electrons must fill the orbitals half. Then pairing should start. After that we can see that 3pz is half filled. So 2 3pz's of 2 chlorines. 2 chlorines, दोनों क्लोरीन का, एक क्लोरीन का 3pz और एक क्लोरीन का 3pz आके end on end overlap. And you know p orbital shape is dumbbell ना? You know p orbital shape क्या है? So dumbbell shape आ गया इधर. इधर सेम शेप का को आया हाइब्रिड्स. इधर सेम शेप का को आया हाइब्रिड्स. इधर डम्बल शेप का को नेचुरल p orbitals आर डम्बल इन शेप. इधर आ गया और इधर व्हाट इज दिस? 3pz. 3pz. orbital is coming and overlapping. End on end. Forming a sigma bond. Sigma bond. That side also. Another p orbital. Another will overlap. End on. Will overlap end on. And the pair of electrons are shared. Which pair? Hybrid में 1 electron है. Hybrid में 2 electrons here. 2 electrons are in each of the hybrids. दोनों hybrid में एक इलेक्ट्रॉन है, वो भी half filled है. The hybrids are also half filled. And the natural 3pz is also half filled. उन्हें आके पेड़ हो जाता. The 3pz comes and overlaps with sp orbital. sp hybrid orbital. Shall we say sp hybrid orbital? sp hybrid orbital से कौन overlap होता? p orbital. Natural 3pz overlap होता, forming a covalent bond, sigma bond. And here also the same story. Okay, so two hybrids of beryllium, okay, and two natural p orbitals. We get beryllium chloride. So now this is the beryllium chloride molecule, beryllium chloride, and you can see that the bond angle would be straight line now. This is a straight line now, so the bond angle would be how much? 180 degrees. The bond angle would be 180 a straight line. On a straight line we know that the angle is 180 degrees. So the bond between sp and 3pz कितना रहता है? Bond angle कितना रहता? The bond angle कितना रहता? हाँ, bond angle कितना रहता? Bond angle कितना रहता? Straight line. What is the bond angle? 180 degrees. And here straight line. Bond इधर है bond, covalent bond इधर है. Bond angle कितना आता? Bond angle कितना रहता? 0, 90, 180. 0, 90, 180. The bond angle would be 180 degrees. Okay, did you understand? Sir. Okay, sir. So tomorrow would you like to have another example? Sir. When will you like to have another example? Only when you are interested in the first example. Or does this example create interest in you? Yes, are you interested to know about other I mean to say formations, other formations and shapes, yes, new molecules? Yes, what is the nayapan in our class today? Hybrids come natural orbitals, overlapping of hybrids with natural orbitals, and that is called hybridization. No. That is not called hybridization. Hybridization means this one, intermixing of natural orbitals and forming equal number of orbitals. That is called hybridization. This is called formation of beryllium chloride molecule. Okay. So, is it done? Sir. Anyone having any doubts? Anyone having any doubts can ask. And anyone who are viewing me also can ask. If anyone are interested in my class also can ask me. The doubts I will clarify. Okay. A wonderful day to one and all. Come on. Go and just practice at home again. Come ready tomorrow. Come ready. Come ready means what does it mean? Understand this completely. Then come to the next class. Bye. Okay, right.